This conference will now be recorded.
All right, let's get started. Good afternoon, everyone. For those of you who have been enjoying the series, welcome back. Today, our Big C Recognized webinar is titled Better Field Testing of Direct Attached Modified Permanent Links. My name is Eric Altizer, Marketing Manager of Programs and Services. For everyone's convenience, our lines have been placed on mute to prevent any background noise. If you have a question, be sure to email us at info@occfiber.com. Since it is a Big C Recognized webinar, there are some instructions at the end of the presentation to ensure you receive your credit, so make sure you stay tuned to that. We're excited to present to you, and giving our presentation today is Derek Steichler. Derek is the Manager of Copper Connectivity based in our Asheville office. Derek, take us away.
Thanks, Eric. Hi, and welcome to our OCC webinar, Better Field Testing of Direct Attached Modified Permanent Links. During this webinar, I do hope to explain to you why a direct attached modified permanent link is not a thing that exists, and hope to teach you the correct meaning of all this and some more stuff. All right, so Optical Cable Corporation, for those of you that don't know, founded in 1983. We do have three locations: Roanoke, Asheville, and Dallas. 360 employees altogether. And we are a premier manufacturer of ground tactical fiber optic cable for the U.S. military and its allies. All locations are ISO 9001 2015 spec registered, and we serve many industries: commercial, military, broadcast, industrial, mining, oil and gas. We are in lots of places. So for our agenda today, we are going to define links and channels which utilize modular plugs. We'll talk about some of the applications and market drivers for field terminable plugs. We will talk about patch cord plugs versus field terminable plugs. Some common mistakes that might get made when testing such things, specifically mod plug terminated links. We'll talk about why does this happen, and I'll show you what the proper ways to do this are, and we'll give you some more resources near the end. So first of all, let's talk about traditional cabling versus NPTLs versus direct attached channel. Now, in this presentation, we're not going to talk too much about direct attached channels, but I do have to talk about them a little bit, so that way you can be clear on some of the nomenclature that we talk about. So first of all, a traditional link. So that's something that has a patch panel and or jack at either end. All right, so there's outlets at either end, and you would interface these things with plugs on both ends. All right, traditional channel is really kind of a permanent link with patch cords in place, and that makes their terminus to be modular plugs. And to interface those with your test equipment, of course, you would use something that's got a jack on the end of it. A lot of people would associate that with a channel adapter, let's say. So now a modular plug terminated link, that's kind of a combination of the two, and it actually has a patch panel or a jack, some sort of outlet at one end, and at the other end, it's terminated with a modular plug. Okay, and direct attached channels, a direct attached channel actually appears physically to be a patch cord. It's got plugs on both ends and no connectors between. But they do differ from patch cords in how they're tested, and we'll get into that a little bit as we go forward. So direct attach, yeah, it's a misused term. I bet a lot of you signed up for this thinking you knew what we were going to be talking about because it said direct attach in it. But I'm going to explain some things for you. So direct attach has been used to describe a lot of different topologies. A mod plug terminated link has commonly been called direct attach, but That's not what it is. It's a mod plug terminated link. Okay. In direct attach, that's typically a Cat8 thing. So a Cat8 direct attach channel is actually not a Cat8 channel. A Cat8 channel allows for a couple of connectors within the channel, whereas direct attach has no connectors. All right. A Cat8 direct attach channel is also not a patch cord, even though it looks like one. Patch cords only get tested for near-end crosstalk and return loss. Channels get tested for a lot more. Okay, Cat8 direct attach channels are not specified for any other category level other than Category 8. Kind of sounds obvious the way it's written there, doesn't it? But actually, a direct attach channel doesn't exist for Category 6A, Cat 6, or 5E. Direct attach only exists for Category 8. So let's talk about some traditional structured cabling. Guys might have seen a picture like this before. You're certainly familiar with this structure where you've got backbone cable coming into a building, comes into a telecommunications closet. You run through your horizontal cable, you end up at a wall outlet with a faceplate and a patch cord going to your desktop. Okay, that's pretty standard stuff. Now let's compare that to a mod plug terminated link. This topology here on top is what I showed you on the slide just previous, with your outlet jack coming into your desktop equipment. A mod plug terminated link gets rid of these connections, the jack and the patch cord, and replaces that with a field terminable plug. And you can use that to access, wireless access points, security cameras. Those are a couple of the biggies. But as a note here, TSB 162, which is cabling guidelines for wireless access points, they do recommend that you wire these things with Category 6A or higher cabling. Okay, that's important. All right, so there has been a market shift that we've seen from wired to wireless. The number of outlets per desk and the number of workstations is on a continuous decline, while enterprise class wireless LAN market sales continues to increase. And I think we've all kind of seen that. So more market shift. There's a growth in emerging markets as well as the use of Ethernet networks to connect and even power other devices, and that will have a positive impact on the market. Yeah, it makes sense, right? Convergence will increase and more structured cabling will be used to wire access points, IP cameras, building management systems, access controls. Yeah, all these things want data, and all these things want power as well. So some of those market drivers, like I said, security cameras, wireless access points, building automation system devices, Wi-Fi 6, if you guys have been hearing that, that's the standard formerly known as 802.11ax. So wireless supports speeds greater than 10 gigabits per second. Okay, remember that whole Cat 6A thing. Building automation systems market is expected to reach $99 billion by 2022. Okay, that's a lot of building automation system stuff, you know. And IDC forecasted that there would be 28 billion connected things in use in 2020. Well, here we are in 2020, and we haven't counted them all, but I'll bet they're out there. So mod plug terminated links, these are gaining industry standard recognition. In ANSI TIA 862B, Structured Cabling Infrastructure Standard for Intelligent Building Systems, there's guidance given in this standard. ANSI BICSI 005 2016, Electronic Safety and Security System Design and Implementation Best Practices, same deal. Okay, and ANSI TIA 568.2-D is the latest version of 568.2 standard, Balanced Twisted Pair Telecommunications Cabling and Components Standard. This incorporates Category 8 direct attached channel specifications, but it also adds mod plug terminated link topologies and testing strategies. You'll find those in Annex F. All right, so there are some problems with mod plug terminated links, and one problem would be the plug. Okay, sometimes people are trying to use patch cord plugs for NPTLs, and the reason this isn't a good idea is there's a few reasons, but you know, one, they're difficult to terminate if you're not very skilled with it. You know, you might actually make the connection, but getting the performance out of it, you know, good luck. So there's inconsistent terminations and performance associated with that. One of the biggies though is that, you know, these plugs are typically incompatible with larger conductors and larger cable diameters of, like, say, Cat6a cables, which, you know, is typically recommended to be installed. It's hard to find a patch cord plug that will actually accept these things and do it correctly. And just as a little sidebar here, kind of is, you know, in 568.0, it does say, there's a statement that says, due to performance and testing requirements, it is recommended that modular cords be factory manufactured. And that's because factories typically have people who are skilled in the art, and they have the test equipment to properly test these cords and make sure that those plugs are put on correctly. Okay, the solution for all that would be a field terminable plug, such as this OCC field terminable plug. These are designed for field installation. They are easy to terminate. They terminate a lot like a jack. You can get repeatable terminations and performance out of them because inside this thing is a printed circuit board, which doesn't change. And they are compatible with the larger conductors and the larger cable diameters that you'll see with Cat6a and whatnot. They also come in shielded and unshielded varieties. So just a little bit about the OCC Cat6a field terminable plugs. These do meet the TIA 568.2 Cat6a specifications. They will support 10G base T Ethernet, you know, 802.3 AN. They'll support cable ODs up to 0.335 inches, and for shielded cables up to 0.354 inches. And they'll support the larger conductors from 24 to 22 gauge. They are a toolless design. Really all you need is a pair of parallel jaw pliers that you could order from us, part number FPJP, and maybe a pair of side cutters. Makes it kind of nice. But if you wanted any of these things, the part number is OCC UFP6A for the UTP version of the 6A plug, and OCC SFP6A for the shielded version of the field terminable plug. So here's a little size comparison of what these field terminable plugs look like compared to standard patch cord plugs. So in this picture on the right, you can kind of see at the bottom here, next to the ruler, is a standard patch cord plug with a boot on it. They almost always have boots. So you can see that that's you know, almost like 1 3/4 inches. And the field terminable plug is just slightly, you know, a few eighths of an inch longer than that maybe. And the shielded plug is just a little bit longer than that because it's got to accommodate some of the shield termination stuff that goes on. But these really aren't all that big, but they're maybe comparable to, say, a standard wall outlet jack or something like that. You can see here there's a quad connector that you would see on, you know, like maybe some active equipment, and we've plugged 4 of the unshielded field term plugs into it, and they all, you know, fit. One thing that I would like to caution with is that we have seen some equipment, you know, wireless access points and whatnot, that where the jack was put in kind of an odd location. And you know, you might want to go look at the equipment that you're going to be plugging into before you use these things, just to make sure that it's going to fit, because we have seen some weird products out there. Another good application for a field terminable plug would be as a consolidation point in a Category 6A application, because you don't typically see Category 6A supported consolidation points, and a field term plug would help with that, because you could use a jack and a field term plug in your consolidation point area. So if that's the kind of structured cabling topology you wanted to use, then these plugs will support that for you. And just to give you an idea how easy these things are to terminate, here's an instruction sheet, and you can see it's really pretty simple. You just strip back the cable jacket, you separate out the pairs, and lace them into the wiring fixture, obeying the color codes. You crunch it down, you trim off the excess wire, and everything goes into the housing. And then you just crunch down the strain relief, and it's done. Nice, reliable, consistent. And just for completeness, I'm going to show you the shielded version as well, which is basically the same thing. The only difference here is, of course, you've got to deal with some shielding elements, but you basically trim those back, wrap your drain wire around, and then everything else is pretty much the same. Just plug it into the plug body, and then crimp it down in the back, and you're done. And OCC also sells a Category 8 field terminable plug, and these meet all the requirements for Category 8 and 568.2, and they will support 40G base T Ethernet, your 802.3 BQ. Supports the cable OD of 0.354 inches and conductors of 24 to 22 gauge. Basically, this is the same kind of overall dimensions as a Category 6A shielded plug. The only difference is we've got some technology buried in there in the printed circuit board that belongs to OCC. And if you wanted a Category 8 version, you could order one from us. That's OCC SFP8. So I wanted to show you a graph of the performance of this plug, and I actually had a couple of reasons to show you this. One is, if you look here, you'll notice that there is a high and a low limit for plug performance. And this is one reason why it's really not recommended for a layman to terminate a patch cord plug. You really need to make the plug's performance hit right in the middle of these lines. And, you know, I know they kind of look like they're far apart way out here at 2000 megahertz, but if you look down here at 500 megahertz, your performance has to be in here, like right in this window. If it's worse than that, of course it's going to be bad, but also if it's better than that, actually I probably shouldn't say better, but if the crosstalk is better, it's still not going to be good, okay? The other reason for showing you this is it's a good visual to show you how much more bandwidth you get with Category 8 than with Category 6A. From 500 megahertz to 2000, you know, that's a lot of distance there. It's like 4 times the bandwidth. So it's just kind of a good illustration. And also, here's a graph of the return loss of a Cat 8 plug. I think that tops out there. I believe that plateau is 14 dB. That's as bad as it's allowed to be, and you want to be better than that. But anyway, that's just to illustrate. So OCC also sells Category 8 direct attach cable assemblies, and they're factory terminated, 100% tested, fully shielded. The standard, the TIA standard for Cat 8 recognizes a max length of 5 meters for direct attach cable assemblies. And just to put that into perspective for you, a Cat 8 max channel length is 30 meters. So that is limitations. You know, it's different from Category 6A stuff as far as channel lengths. But these will support your 40G base T applications, and they are more cost effective compared to existing 40G technology. And specifically, I'm talking about like CX copper technologies, which a lot of times are proprietary to the active equipment manufacturer. You know, you buy manufacturer A's switches or whatever, you probably will have to buy their direct attach assemblies, which have funny little connectors on the ends of them, and you know, they are proprietary and they charge more money for those. So you know, the ubiquitous RJ45 plug is a good way to go for that. And here's showing you just a comparison of a patch cord versus a direct attach channel. You can look at this picture on the right and see that these things, they do look similar. It's just a cable with plugs on the end. However, there are some differences, and the transmission performance parameters they get tested for is a biggie. So patch cords only get tested for near and crosstalk and return loss. Whereas a direct attach channel needs to be qualified for all these parameters, such as insertion loss and PS Next, ACRF, PowerSum ACRF, prop delay, delay skew. These are all specified for direct attach channels because it actually is a channel. Just a side note here as well, 568.2. The -D revision now recognizes that there can be solid conductors in patch cords. Not sure how many people were aware of that, but previously only stranded wires were recognized. So that has changed. So how do you test these things? Well, here's the old test method, and like that bullet says, some test methods don't measure the performance of the field terminated plug, and this is one of them. And we feel that, you know, a lot of people are probably still thinking this is okay, but I'm here to educate you. So if we want to talk about this, the first things that we need to do, we need to look at what actually a standard link configuration, link and channel configurations look like. So let's look at this permanent link configuration. This is right out of the 568.2 standard, okay? And the important thing here is where it says permanent link under test, and you see those arrows are pointing to these lines. Everything between those lines gets tested, okay? When you hit the test button, you're getting data for all the stuff that's in between those lines. All the stuff outside those lines does not get tested. So these items labeled F, which is your test equipment cord, okay, those are not part of the test. They won't be included in the results. All right, same thing for channel configuration. But you'll notice there's a little difference here with the channel configuration because we're kind of including these patch cords at the end. And you'll notice that so everything between these lines still gets tested, but again, everything outside the lines not getting tested. And you'll notice what's outside these lines, that's a jack and that's a plug right there, okay? A jack and a plug. That's a mated connection. It is not getting tested in the channel configuration. So the modified link test configuration, this is what a lot of people called it, and we're still calling it that here because it's really not correct, and we want to distinguish that, all right? But the way that would work, what people were doing for a while was, okay, so you've got this topology here, and it's got an outlet on one end and a plug on the other. So to interface the outlet, you use your permanent link adapter because that's what you have. And on the field terminated plug end, you're going to use your channel adapter because, well, that's what you have. And you have a plug here, and it plugs into a jack. So, you know, how else are you going to do this? Okay. Well, if you'll remember that little diagram, everything behind the line here, not tested. All right. That's not going to be tested. That's not going to be included in your results. Well, why is this a problem? Well, I think it already sounds like it's a problem, right? So first thing I want to say is the testers are performing as they should. The TIA defined a channel as I have shown you, and so the testers are rightly excluding that mated connection because it's not part of a channel. Okay, and the test operator really might not be aware that that happens, and really might not know what the tester's capabilities and/or limitations may be. The other thing is that mod plug terminated links, these are relatively new, and the test methods are relatively new. So they haven't been with us all that long, and haven't had a lot of time to soak in. But the end takeaway is that the results will not include that plug connected to the channel adapter. You're going to hear me say that quite a lot, so I hope it gets drilled into you. So we did set up some testing to kind of prove what's going on, and that testing included making an NPTL and then making it with a very poorly terminated plug and using the incorrect test method, and then swapping the poorly terminated plug for a high performance field plug and running the incorrect test method. And then back with the poorly terminated plug using a field plug test adapter, which I'll talk to you about in just a few moments. And then also with the high performance field plug with the field plug test adapter. So this was a category 6 10 meter mod plug terminated link with the commonly used method, hooked up just the way I was showing you previously. Plug is connected directly into the channel adapter, and the result was that it passed all tests, and there was 8 dB of margin for the next result. And it looked like this. So this next result, that's pretty nice. And what I'd really like to point out with this result to you is that it does look correct. There doesn't seem to be anything wrong with this result. That looks like what you would see with a 10 meter 2 connector permanent link. So looks like you're getting the right kind of data there. Next, we do the same test with a high performance field plug, and it also passes with 8 dB of next margin. And so that kind of raises a question, right? Because you were thinking, well, shouldn't the high performance field plug be better? Well, maybe it should. So to solve this problem, like I said, the incorrect method, the tester ignores the plug and jack and the channel adapter, masking the true performance of the link. There is a better way to do this. You could utilize a field plug test adapter, where the adapter plug is connected to the test equipment, not the field terminable plug under test, the thing that you're trying to get your test result on. So I'm going to tell you now about the OCC field plug test adapters. These are manufactured for a specific performance category. They're available in Cat 5e, Cat 6, and Cat 6a flavors. The thing is, you have to use, if you're testing a Category 6A NPTL, you really have to use a Category 6A test adapter, okay? And the same with Cat 5e. If you're testing Cat 5e, you really need to have a Cat 5e field plug test adapter. These aren't backwards compatible like you're typically used to, like if you were to put a Cat 6A jack in a channel for 5e, of course it's going to pass 5e. That's not true with these test adapters, and the reason why that is because these the jacks used are compliant to 568.2-D clause C.5.2, which talks about patch cord test adapter requirements and the centering of those things. And without boring you too much, the main point of this is that the centering is based on bandwidth. And so a Category 6A center-tuned jack is center-tuned between 1 and 500 megahertz, all right? A Category 5E center-tuned jack is center-tuned between 1 and 100 megahertz. So if you were to try and use that Cat 6A jack for a Cat 5E link, it would definitely skew the results. So you wouldn't be getting the correct data out of that. So you don't want to do that. You want to use the correct category for whatever you're testing. Okay. So can you just make your own? Well, not really. So again, I will point to the statement, due to performance and testing requirements, it is recommended that modular cords be factory manufactured. Yeah, that still holds true with these things. You want good quality cords and plugs. And the other thing is that the field plug test adapters, they utilize modular cord test heads. Some people know them as patch cord test adapters. And they are, again, they're centered on the requirements 568.2 and Annex C.5. And there's a lot that goes into that. There's you need a network analyzer and some specialized test fixtures and a high level of technical expertise. And you can see this picture of this hapless character trying to tune a jack right there. You don't want that to be you. Let's go back to our mod plug terminated link test. Now we're going to take our poorly terminated plug, and instead of plugging our poorly terminated plug right into the channel adapter, we're going to actually put this field plug test adapter into the link. And we're going to run the test, and now you'll see we're going to get negative margin. So all of a sudden, the real performance of that plug gets shown. Here's a comparison. All right, the graph on the right, that's what I showed you earlier that looked real pretty and nice. Here's what the performance of that plug actually was. Okay, if you were to just trust this graph on the right and say, hey, it's good to go, guess what? It's not. It's so bad, it's hiding the limit line for the link there. So obviously there's a difference. And then we ran the same test with the high performance field terminated plug. And now we get, it passes all tests by 7 dB of next margin. So really, that shows that the field terminated plug is doing its job. It's a good plug, and now we've unmasked it, and we can see that it is a good link. Why the difference? Well, because the incorrect method ignores the plug at the channel adapter. Okay, that it was just never included. And the better method is to use a field plug test adapter. That puts the field plug now as part of the tested link. It moves it out into the part that's being tested. All right. All right, so where are we now? Well, in 568.2 D revision, they formally recognized mod plug terminated links, and so this was published in 2018. However, the need has existed for quite some time before this. I mean, we were getting calls from customers saying, I put a plug on the end of this thing, and how do I test it? And saying, well, that's not really a standard test. But people kept asking and kept asking because that's what they want to do. They had a need for this. And so we looked at it and we said, well, yeah, okay, I think there's a way that we can get around it. And so what we did was we used our experience in test and measurement, and we came up with the field plug test adapter. And now our customers had a way of testing MPTLs. And so here's what a mod plug terminated link looks like in the 568.2-D standard. So this diagram, it looks very similar to diagrams that I showed you previously for channels and permanent links. This one is very similar to a permanent link because that's what an MPTL basically is. And so, if you look over here on the left, that starts out kind of, as the thing that you're well familiar with. And but as you go over here to the end, notice again these horizontal line or these vertical lines, they're showing you where the link starts and ends. And notice now that this vertical line here is capturing this mated connection. Okay, and this mated connection, you can see it's labeled F and B. So the F is a mod plug, and B is labeled as a patch cord test head as qualified per Annex C or D. And a patch cord test head, well, that's what OCC makes a lot of, and we supply a lot of these to the tester manufacturers. As far as I know, we're the only ones that are set up to do this, and we're the only ones with an assembly line and the expertise and the product that's able to get this done. And so whenever they wrote this standard, they kind of had that in mind, and they just said, well, let's use patch cord test heads because that's actually what we want to do. And we had been proving that you could do this for a time before they actually put it in the standard. So it actually made sense. So here's what the real world test configuration of a mod plug terminated link looks like. Turns out the real world looks a lot like a cartoon. But if you look here on at the near end of this link, you've got your permanent link adapter as you normally would, interfacing into your patch panel. You go through your horizontal cable. Now you've got your high performance field terminated plug. And instead of plugging into a channel adapter, what you've got now is a mod plug terminated link adapter. And it might look like a channel adapter, but it is a different beast. There's differences in here, and the biggest one being that it has a patch cord test adapter inside of it. Okay, and then you would make your settings to say that you are testing an NPTL, and it would set limits that are pretty much equal to a permanent link. So you might ask then, well, can I just use my patch cord test adapter module if you have one? Well, I think actually, so the latest testers that support the standards, some of them probably do use the same adapter for patch cords and NPT mod plug terminated links. In fact, I know of one company that specifically they do. But actually, legacy testers, it's almost guaranteed that they won't, and that's because back when they were supporting testing of patch cords, what they had in mind was, okay, we're going to test a patch cord, and it only needs to test near and crosstalk and return loss. And while that might not seem like a big deal, to get all these other parameters, there actually needs to be some different kinds of terminations and some switching built in, and probably some different electronics and software that goes along with it as well. So it's pretty much guaranteed that you won't be able to use an older patch cord module to test an NPTL. The tester will probably scream at you if you try that. So basically, since of course I can't tell you how every tester manufacturer is going to operate, I think really just consult your tester manufacturer and ask them what they say to do. They'll probably tell you to buy the latest and greatest. And what should you do? Well, yeah, the most accurate test will be one that follows the latest standards. If you've got an old tester, the best thing for you to do is really, if you're not going to upgrade, then at least for the time being, you want to use an OCC field plug test adapter. That's going to give you the most accurate test that you can achieve with that older tester. And the latest testers that support the standards, again, they have NPTL stuff built into them. And here's a couple of screenshots of some testers showing the NPTL capabilities. In fact, you can see they do NPTL and PoE all at the same time, which is a pretty nice little functional thing. And you can get a 25-year warranty on mod plug terminated links. Here's the deal. You need to be MDIS certified with us. And obviously you need to be using all OCC product. And then the other thing is that you need to test, the test results need to come from a field tester which does support mod plug terminated links, or you need to be using an OCC field plug test adapter. Either of those things will be good with us. We will warranty your product. And so in summary, testing a mod plug terminated link with a channel adapter does not accurately measure performance. I hope you all walk away from this realizing that. Field plug test adapters will allow for accurate measurements of NPTLs if you're using legacy testers. So if you got an old tester, please have an OCC field plug test adapter on hand so that way you can get the correct results and you won't get some of that really bad data like we were showing earlier. The latest testers will fully support the measurement of mod plug terminate links. However, it is still important to ensure that you've got the settings set right and you're using the adapters correctly. Because you could still take a new tester and throw a channel adapter on there, and that new tester will still ignore anything that's plugged into the channel adapter because, hey, channels are still a thing and the plug at the end of a channel is still ignored. All right, so just keep that in mind. And that's the end of my talking.
Awesome. Thank you, Derek, for that information. Included in this slide are some resources on our field plug test adapters, like you mentioned, some field terminable plugs, and copper information. So all these resources will be included in an email to you guys later today or tomorrow, and they can also be found on occfiber.com, as well as our various social media channels where we continue to communicate with you guys on new products that are launching, promotions, and webinars of that sort.